Hi all, Rob Simpson, Director of Development for Aegis Inc. with another video update on the Tres Lagunas project and the due diligence behind it and where it's going. The Salton Sea Authority has formed an independent council to review saltwater importation plans, and ours is one of them. Dr. Suri, I hope I'm pronouncing that right, of Temple University has been appointed the chair of this independent review council or panel. And this panel consists of multiple PhDs in closely related fields, mostly dealing with water, environment, and other subjects. Previous work in the Northern Gulf region includes this paper from Drs. Mitchell and Ivanova. Drs. Mitchell and John Mejia comprise one team of experts. We wish to conduct a mesoscale climate model in the region. This previous work indicates a mechanism in which when sea surface temperatures rise in the Northern Gulf early, you have an Arizona monsoon, and when they rise late, you have a New Mexico monsoon. Another team we wish to have model this subject matter is Dr. Volker Wolfmeyer and Oliver Branch of Earth Systems Solutions with a home office located in Stuttgart, Germany. For hurricane tracking in the Gulf of Mexico, I count at least 12 different tracks here from different models. The North American monsoon modeling budget is far less, and 40 million people depend on the flows of the Colorado River. Please note that Colorado River allocations are currently at 16.5 million acre-feet per year, which is far above what flows actually are. With total flows in the Colorado at about 12.5 million over the last decade or so, but declining since 1925 or so. We need to have better prediction and models for the monsoon so we have a better grasp on water availability in the West. The purpose of this video is to examine how the Tres Lagunas project or other projects would affect the cone of uncertainty for the monsoon. We'll ask a few questions and look at satellite imagery regarding the mechanisms that help form and steer the direction of the monsoon. In 2021, yes, sea surface temperatures did rise in the Northern Gulf early, and we did have something akin to a Arizona monsoon, but it did not follow the typical model as shown here. The high and low pressure zones were all over the place. There was a lot of different aspects going on this year. It should also be noted that this image depicts the strongest monsoon, where it sucks in water vapor from 3 different directions. More accurate modeling is needed to understand how and when more moisture is sucked in from each of these directions. One important aspect that we're going to examine later in this video is the timing of the 29.5-day lunar month and the spring neap tide sequence that occurs within that month. In 2020, tidal amplitudes maxed out at 5.9 meters at El Golfo de Santa Clara and were noticeably earlier than the following season. Both of these sequences are obviously from August in 2020 and 2021. In 2021, the tidal amplitude was about 6.1 meters. The primary modelable difference is that 5.9 is just shy of getting a lot of water onto the floodplain. 6.1 is enough to do so due to a doubling of tidal levels north of Montague Island in the mouth of the Colorado River. Sorry for a bit of confusion, but the Colorado River this far south no longer exists. Flows are zero, transport of sediment is zero. The entire Northern Gulf environment is experiencing great amounts of salinity increases that have already killed off much of the aquatic biosphere. The GOES satellite water vapor videos shown subsequently cover roughly 9 o'clock in the morning through the end of the high tide, because I was curious to see what happens when really high tides occur when water temperatures are at about 30 plus degrees Celsius. Hadley cells are part of spaceship's Earth's ventilation system and move heat from the equator to the poles. Descending Hadley cell air at 30 degrees north is largely responsible for the creation of desert regions all around the world. In our neck of the woods, 30 degrees north is at this black line. In 2020, this is a morning dose of descending Hadley cell air that is very dry and moves into the Colorado River Basin. This video shows GOES satellite data, courtesy of NOAA, around August 11th, or in the morning of August 11th. And you can see how it hits the ground and almost causes a shock wave-like effect, expanding, pushing moisture north of it to the north, basically expanding radially. A possible source for large Hadley cell events during this time of year could be hurricanes forming near the mouth of the Gulf of California. This is actually from August of this year, and Tropical Storm Ignacio did form into a hurricane. This imagery is part of a model of Gulf of California tides provided by CCs, and it shows where a doubling of tidal amplitude occurs north of the island archipelago, just below the black line here. You can see where that chain of islands is. This is a cross-section of the entirety of the Gulf of California along the long axis. This area right here is known as the sill, and everything north of that, or to the left in this image, is the northern Gulf. Everything to the south is the southern Gulf. When tides come in, a large amount of water, even from great depth, is pushed up over the sill and into the northern Gulf. An effect of the incoming tide is to raise a large portion into the red areas, at least temporarily. This really increases the surface area and altitude of the water. So what happens when 30 plus degrees Celsius water gets spread out over a much larger surface area during high tides? We'll also touch base on tidal energy in the Northern Gulf, as we will be using tidal energy alone to push waters through Laguna Salada and about 35 kilometers down south from where it currently exits. This will increase the thermohaline cycle of the Northern Gulf. It should also be noted that when the water is again confined, heading north of Island Montague into the estuary, it again doubles in amplitude. This is a process known as tidal amplification, and we cover that in great detail in the previous video. The following video clips cover August 7th through August 11th, morning to afternoon building tides. Each day roughly covers the time frame from low tide to high tide, and note that the high tides at El Golfo Clara occur at later times in the afternoon on each day. So essentially, we'll be observing water vapor creation over 5 days during a building spring tide that's a bit larger than the one shown here, with amplitudes up to 6.1 meters in El Golfo de Santa Clara. So on the morning of August 7th, a moisture plume starts moving northward past the archipelago, perhaps aided by incoming tides. By the morning of August 8th, the moisture plume has grown in size and intensity and still moving northward. By the morning of the 9th, the moisture flow has reached the tip of the Northern Gulf, intensified, and moves northeastward. These moisture plumes occur at about the same time that the tide arrives. This is still the morning, early afternoon of the 9th from a different angle. Note the spread of the Hadley cells. On the morning of the 10th, a Smaller but still noticeable plume of descending Hadley cell air hits the northern Gulf and pushes much of the moisture to the north, further to the north. It also evaporates much from the Baja California tidal floodplain and Laguna Salada. The 72 hours prior to the morning of August 10th, more precipitation fell in the Laguna Salada area in these 3 days than typically happen in 2 years. A 12-hour accumulation taken on the morning of the 11th indicates that the Cucapa Mountains, separating Laguna Salada from the Mexicali Valley, got more than an inch of rain, which is a lot for this area as well. So, by the morning of the 11th and the big Hadley cell event, a lot of moisture is already to the north and gets further north, causing thunderstorms to erupt further to the north, along with daily heating. The Tres Lagunas project will not control or change the nature of the tides or the Hadley cell descending air, but it will create more water vapor further north that can be pushed up into the already going monsoon. While the eastern plume heads over Arizona, the western plume heads up the coast, and it looks like it drags a bunch of moisture with it and really creates a big plume of moisture that re-enters the monsoon west of the Rockies. Now, I'd normally consider this a fluke, but here's a clip from 2020 when I made a video regarding the dry lightning strikes that caused the fires in August of that year. A departure from the New Mexico monsoon started on August 15th with the appearance of that slightly rogue plume of moisture and associated convection and lightning strikes. This is August 16th. August 17th, when most of the fires were started, and August 18th. Some fires, not so bad though. Okay, so we started as a New Mexico monsoon and we quickly shifted to a Arizona monsoon for a few brief days. In the 2021 monsoon, most of the northward bound moisture from the southern Gulf heads to New Mexico, while northern Gulf evaporation heads to Arizona, where it will eventually encounter the Rocky Mountains. In the Colorado River Basin, rain starts to fall as soon as the water vapor hits basically the Colorado Plateau and has barriers on both sides to funnel the moisture into a self-reinforcing precipitation making machine. While many aspects of the work produced by Drs. Famiglietti and Lowe back in 2012 is still being debated, including a roughly 15% increase in precipitation over the Colorado River Basin, I do agree with a more generalized version of this statement that when additional waves of moisture bump into any version of the monsoon throughout the season, it's like throwing fuel on a fire, especially when that vapor gets into the Colorado River Basin. Using a diagram from their paper, the additional water vapor from the northern Gulf and Imperial Valley goes into the basin, causes a increase in precipitation, which causes a increase in evapotranspiration the next day, which draws in more moisture from essentially everywhere south and maybe from the west, maybe from the east, but it causes an increase in eventual river flows, which is beneficial to everyone in the southwest. When thunderstorms form over mountains in the basin, they pull in air from all sides. If it's wet, it helps things. And while water vapor can escape over the Rockies to the east, it's more difficult. Orographic lift causes the rain shadow effect, meaning most of the water stays to the west. A purpose of these studies we intend to conduct is to study all aspects of the northern Gulf extending to the northern tip and beyond of the Salton Sea including evaporation from the Salton Sea, from the Laguna Salada, from the IID fields, and evapotranspiration. Here, all forms of water vapor creation may be seed vapor for this anthropogenic loop of increased precipitation. Having a consistent and persistent form of evaporation on this scale should seed the monsoon. Part of the Tres Lagunas project is to make these studies and understand how much evapotranspiration in total from the island archipelago to the Coachella Valley contributes as seed vapor for monsoonal episodes. And yes, the shallow areas of the northern Gulf evaporate more, they get warmer quicker. They actually contribute to the heating of the northern Gulf from May 15th through August. At present, 60 to 100 million acre feet per year enter and leave through the mouth of the Colorado, and this does have an effect on the gyre that exists throughout the northern Gulf. By placing a roughly 2-meter high check dam in the channel north of Montague Island and using the impound facility created by the hand of God on Easter Sunday 2010, it becomes easy to use excess tidal energy to drive a circulation current through Laguna Salada and back down 35 kilometers south, exporting water with temperatures up to 35 degrees Celsius and 40 parts per thousand in terms of salinity. Parts of the panel's study may include concepts like project viability. Is the project possible? Fatal flaw analysis. Are there cost issues or environmental issues that may impact the long-term viability of the project? And overall cost-benefit analysis. How much does the project cost? How much environmental or economic benefit is introduced by the completion of the project? Does the project have a potential to earn a profit? Finally, and perhaps most importantly, is what's in it for Mexico? They are a sovereign nation, and we can't just dictate terms. They are also signatories to the Paris Climate Accords and have dedicated money to do so. So what socioeconomic benefits and or environmental benefits are afforded to Mexico through the completion of the project? Looking at a pipeline project to import water from the Sea of Cortez and selecting the shorter of the two routes, the budget for such a project, designed to import about 5 million acre feet a year, would be about $1.8 billion and cost about $18 million a year in electricity to run. Here, the water source would be located in about this area. Basically, we would drill wells and pump up water from a saline aquifer with salinity rates probably approaching 40 parts per thousand. Such a system will probably not hurt the Alto Golfo Biosphere Reserve, but it certainly will not help it. Secondly, this budget does nothing for the internal properties of the Salton Sea as you dump the water out in between the New and Alamo rivers. Please remember that importing salt water means that you're importing salt as well. While the Tres Lagunas overall project can support many blue and green projects, building a pipeline to pump over the small ridge at the border to allow the flow of water to move downhill about 240 feet will allow us to generate electricity. Secondly, the flows of the New and Alamo rivers will displace the existing salt water and drive it counterclockwise back into the same location where we're going to import the salt water to. Key here is the size of the salt sink. Using previous work, we can get a really good idea for monthly and annual totals of evaporation from the entire surface, but also understand that each unit area evaporates about 6 feet. So every acre of salt sink will evaporate about 6 acre feet of water per year. So if you import 500,000 acre feet per year and make the surface area of the salt sink 90,000 acres, it will evaporate 540,000 acre feet per year. So if all flows into the salt sink come from the west, or the purple area, flows into the purple area in the oval in red would be about 40,000 acre feet per year. The larger the surface area of the salt sink, the greater the flows through and into the purple area. So long as we keep flows in the New and Alamo River above 800,000 acre feet per year and salinity levels about 4 to 6 parts per thousand, this should make a good environment in the smaller, more sustainable perimeter lake-like Salton Sea. Keeping salinity levels low in the blue-green areas provide an excellent chance for phytoremediation, floating islands, similar projects, because the plants are more productive at removing pesticides and or excess fertilizers from the water column when salinity levels are pretty low. So even the shorter pipeline here is 3 or 4 times as long as the Tres Lagunas project pipeline, and any long pipeline is going to cost energy due to the excess friction involved in a long skinny pipe. Importing from the Pacific would be about 10 times the cost of both construction and electricity use to get water to the Salton Sea. Looking at a canal type proposal, one must understand that at the source in this area, the tidal range is about 10 meters. The depth of the canal is supposed to only be about 10 feet. How do you control water levels in the canal? It looks like they intend to excavate the canal all the way to the Salton Sea. If that is the intent, I know this type of equipment. I've moved a lot of dirt in my career. I think that area right there would cost at least $500 million. This area up here, if it's unlined, are you going to put an unlined canal carrying 40 part per thousand salt water above and in really close proximity to the unlined portion of the All-American Canal and the farm fields? I think that would be a bit difficult to get permitted. Secondly here, using this type of equipment to conduct the work is probably a mistake. Equipment looking like this is going to have a hard time in the local environment. Hazards of getting stuck in the mud are well known to the locals both along the shore but also in Laguna Salada. You can see the salt here. Laguna Salada is below sea level, and the tides provide sufficient hydrostatic pressure to pump water through the aquifer and bring it very close to the surface, leaving only a very thin crust of drivable, sort of dry dirt. Using traditional excavation machinery in such an environment will probably be problematic at best. The Tres Laguna project plans to use hydraulic dredging, which is far cheaper anyways, but it's the right tool for the right job in this location. It can be delivered on the back of a truck, and it can pump or eject materials 2,000 feet away without a booster pump, miles away with extra booster pumps. So, final point, flooding the Laguna Salada will create more persistent, consistent moisture plumes from the northwestern end of the Sea of Cortez, and this should increase precipitation rates in the Colorado River Basin. We do not want to go the way of Tulare Lake or Owens Valley Lake, where we essentially dried out these entire basins. This type of future would not only reduce flows in the Colorado River, but exacerbate existing health hazards. The Pacific Institute estimates a 30-year, $70 billion unfunded liability for exposed playa at the bottom of the Salton Sea. This is the Carlsbad desalination plant in San Diego. It cost $1 billion to produce, creates about 50,000 acre feet per year at an expensive price. It takes lots of electricity to run such a plant, and it costs $2,000 an acre foot or more for the jurisdiction. There is lots more to all these issues, and I'll be happy to share those with you later. But we all know that rain helps the carbon sink, it helps plants grow. The Tres Lagunas project will cost $1 billion to maybe $1.2 billion, but will produce far more fresh water availability for the Southwest than a $1 billion desalination plant, and use only entirely green energy. In fact, it's going to generate green energy. It will also draw more water through the archipelago, reducing salinity in the Alto Golfo Biosphere Reserve. It will restore and preserve a large portion of the Pacific Flyway.